The teaching at Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time, and they made learning a very fantastic experience.
Hi guys, कैसे हो आप लोग? This is Saurav here and welcome to the last session on electrochemistry. I am very sorry we started off a little late because of some tech issues, but I'm pretty sure that we are going to have a wonderful session because this is a quiz session on electrochemistry. Amazing tech, Preetham, hello guys, Ajay, Gabbar. When will organic chemistry start? ज़्यादा दिन नहीं लगेंगे, अभी स्टार्ट ही हो जाएगा. हेलो स्वतंत्र, हेलो अनुपम. सो to all those guys who don't know me, I'm Saurav Goswami and we have until now covered a substantial amount of stuff. And before going on to that, please do like, share and subscribe every video, everything that goes on the channel, and just make the word reach out to your friends. The things that we have covered is everything that you can see over here. यहाँ पे सारी चीज़ें जो लिखी गई हैं सब कुछ हमने कवर कर दिया है. We have covered everything. So we have covered galvanic cells, electrolytic cells, Nernst equation, characteristic behavior, Faraday's conductance, Colruy's electrolysis cases, concentration cells, and also the problems on that. Okay, so today's session is exclusively on question solving. We'll be taking some questions which have come previous years in JEE Mains as well as Advanced and in other examination like BitSat. So these questions are objective in nature with one answer correct or more than one answer correct. So please try to solve them real time. जितनी जल्दी आप solve करोगे उतनी जल्दी हम आगे वाले question पे जाएंगे. So but you're not ready, Ajit. I'm pretty ready. Okay, so the thing is, चलिए start करते हैं आज का session. And the first question is this. Okay, please read the question. The question says, an aqueous solution containing 1 mole per liter of cupric nitrate, AgNO3, mercurous nitrate, MgNO3 is being electrolyzed using inert electrodes. The value of standard potentials is given as this. Ag plus converting into Ag is 0.8, Hg2 2 plus. So it is Hg2 2 plus converting into Hg is 0.79, Cu2 plus converting into Cu is 0.34, Mg2 plus converting to Mg is minus 2.3 volts. With increasing voltage, the sequence of deposition of metals on the cathode will be. So when I increase the voltage, metals will get deposited on the cathode. क्योंकि ये reaction हम reduction कर रहे हैं, so ये metals cathode पे deposit करेंगे. I have to identify what is the sequence which will deposit first, which will deposit second. ऐसे करके कौन सा deposition होगा. So options are A, B, C and D. बताइए option क्या कौन सा होगा? Which is the right option? A option is Ag, Hg, Cu, Mg. B option is Ag, Hg, Cu. C option is Mg, Cu, Hg, Ag. D option is Cu, Hg and Ag. The right answer is Shani says A, Vikas says A, Vanshika says B, Vikas Tiwari says A, D, B. बहुत सारे तरह के आंसर्स आ रहे हैं. ओके, बहुत सारे तरह के आंसर्स आ रहे हैं. तरीका ये होता है, the right answer my dear students is B. The right answer should be B. Okay, the right answer should be B. The right answer B यहाँ पे लिखा गया है. Okay, so इसको C मत मान लो, this is B. The right answer is B. कैसे होगा? So try and understand that will undergo reduction earlier, which has a delta G for reduction negative. I have to identify delta G naught for reduction. Delta G naught for reduction जिसके लिए negative होगा, that will be deposited first. So सबसे ज़्यादा negative जिसके लिए होगा, that will be deposited at the starting of the passage of electricity. उसके बाद जिसका कम होते जाएगा उसी sequence में आएगा. Okay, so डेल्टा जी नेगेटिव, मोस्ट नेगेटिव डेल्टा जी विल बी फॉर दिस वन, क्योंकि इसके लिए ई नॉट सबसे ज्यादा पॉजिटिव है. We also know that delta G naught is equal to minus NF E naught. Don't worry about the number of electrons. Remember that delta G naught is proportional to E naught with a negative sign. So जिसके लिए सबसे ज़्यादा डेल्टा G naught रहे, जिसके जितना ज़्यादा E naught रहेगा, उसके लिए डेल्टा G naught भी उतना ही नेगेटिव रहेगा. जितना पॉजिटिव उतना ही नेगेटिव. सो मोर नेगेटिव मोर फीजिबल, मोर नेगेटिव more feasible. Now the thing is, I will take this into consideration, but why I am not taking Mg into consideration? Somebody is asked, I am not lava Skati. Okay, somebody has asked that why magnesium is not included. That's a very good question. That why magnesium is not included is because magnesium के पहले hydrogen आ जाएगा. Okay, hydrogen is not written over here, but you have to remember that if you take these elements before magnesium, hydrogen will come into picture. Hydrogen पहले reduce हो जाएगा magnesium से, okay? और hydrogen completely reduce नहीं होता है. H plus the reaction is quite slow, so H plus का complete reduction नहीं होगा. H plus यहाँ पे आएगा, H plus converting into H2, this will be 0.0 volts, and this will come after that. So magnesium cannot be extracted from the solution. That is the reason metallurgy में I cannot extract magnesium from sea water. Aqueous solution से नहीं extract कर सकते इतनी आसानी से, क्योंकि before extraction of magnesium or these elements which are highly reactive like magnesium, calcium, lithium, sodium, hydrogen will undergo reduction. Okay, the right answer is therefore AgHgCu. Magnesium will not even come into picture. तो जिन्होंने A मार्क किया है बहुत गलत नहीं किया है, बट याद रखो ये मिस मत करो. This is generally not given. Okay, so the right answer will be B. Clear? चलिए, let's move on to the next question. Next question is this. The standard EMF of a cell where permanganate oxidizes ferrous ion is 0.59 volts. The equilibrium constant for the given reaction is approximately. Okay? The equilibrium constant for the given reaction is approximately. एक reaction जहाँ पे permanganate is oxidizing ferrous. What will be the equilibrium constant for that reaction? Because you have been given the standard electrode potential. कितना आंसर हो सकता है बताइए? 50, 10, 10 raised to 50 or 10 raised to 5. No C और A. यार सॉल्व कीजिए. ट्राई टू सॉल्व दिस. सॉल्व करने से ही आंसर आएगा, गेस वर्क मत करो. ओके, a lot of people are saying B, A, D. फॉर्मूला पता नहीं. आंसर D. देखते हैं. ओके, देखते हैं कैसे सॉल्व करना है. सो इसको सॉल्व करने का तरीका बहुत सिंपल है, बट टू सॉल्व दिस क्वेश्चन आपको ये जानना होगा कि व्हाट इज द रिएक्शन बिटवीन परमैंगनेट एंड फेरस आयन. परमैंगनेट एंड फेरस आयन के बीच में रिएक्शन क्या होता है? द रिएक्शन इज दिस. MnO4 minus reacts with Fe2 plus changes to Fe3 plus and it changes to Mn2 plus. This is happening in an acidic medium. Okay, this is happening in an acidic medium. दिखा नहीं है लेकिन this reaction is happening in an acidic medium. अगर इस reaction को acidic medium में हम करते हैं, then for this reaction number of electrons lost is 1, so n factor इसका 1 हो जाएगा. Okay, for this reaction Fe2 plus converting into Fe3 plus, the reaction is losing Fe2 plus is losing 1 electron, and manganese plus 7 oxidation state changes to plus 2. So when plus 7 changes to plus 2, n factor will be 5. Okay, n factor will be 5. This will be 5. How do we balance the reaction? यहाँ पे 5 लिख देंगे और यहाँ पे 1 लिख देंगे. This will balance the number of electrons. This will balance the number of electrons. हमें सिर्फ electrons को balance करके काम चलाना है, because if I balance the whole reaction, that is not going to prove anything. I need electrons for my question. So can you tell me how many electrons are exchanged? If Fe2 plus gives out 1 electron and Mn takes up 5 electrons, how many electrons are exchanged? कितने electrons exchange किए गए हैं? Okay, how many electrons are exchanged? बताइए. 10 electrons, no. 6, no. 1 electron is given out. 5 electrons are taken in. Number of electrons exchanged will be the maximum value of these two. Okay, इन दोनों का LCM होगा. 1 और 5 का जो LCM होगा, that will be your answer. Okay, and 5 electrons. A lot of people are saying something incorrectly. Okay, try and understand. Number of electrons which are exchanged will be the LCM of the electrons which are being lost or gained. Okay, so number of electrons हम ले लेंगे 5. Okay, once this is done, I have to use something else as well. So हमारे पास दो इक्वेशन आता है. I have two equations. I know that G is equal to G naught plus RT ln K. Okay. Also, I know that G naught is equal to minus N F E. So, can I say, मैं इसको लिख सकता हूँ. I can do this. So I have to equate these two things. मैंने इनको इन दो चीज़ों को equate करना है. How would I write them? N represents the number of electrons, so that will be 5. F is 96500. E value is 0.59, which will be equal to 2.303. R value is 8.314. Temperature is 298 times log K. Okay, times log K. Please look over here. देख लीजिए इस चीज को. N value is 5, F is 96500, E naught is given as 0.59, R value is 8.314, T is 298. ln K को log base 10K में change करने के लिए I will multiply it with 2.303 times log K. I will get my equilibrium constant from this. If I divide this value, this large value from this, I will get the answer as 10 raised to 50. Okay, answer कुछ 10 raised to 50 आता है. ठीक है, this is how we solve this question. Remember to use this concept that the number of electrons will be 6. Don't ever say that number of electrons will be the sum of the electrons which are given out and taken in. ठीक है, n is equal to 5, उसके कारण ही ये आंसर आ रहा है. आप अगर आप 6 ले लोगे या 7 ले लोगे, 4 ले लोगे तो गलत आएगा. ठीक है, चलिए फाइन. चलो, very good Vanshika. Let's take the third problem. The standard reduction potential of Cu2 plus changing into Cu and Cu2 plus changing into Cu plus is 0.34 and 0.16 respectively. The standard electrode potential of conversion of Cu plus to Cu half cell कितना होना चाहिए? What should be this answer? ये बहुत simple question है. How do we solve this question? We have learned this in the previous sessions कि इन questions को हमको solve कैसे करना चाहिए. So Cu2 plus converting into Cu2 plus converting into Cu. What is this reaction? Cu2 plus converting into Cu. This is reduction. Cu2 plus converting into Cu plus is reduction. और ये क्या reaction है? ये भी reduction है. So when I get a reaction which is, when I get two reduction reactions और उससे मुझे एक third reduction reaction के बारे में निकालना है, I will use a very very important method which is known as the free energy method. Okay, it is known as the free energy method. The options are over here. I'm very sorry. Options are over here. Free energy method बोलते हैं इसको. Free energy method कैसे यूज किया जाता है? Okay. How do we use free energy method? So देखो कैसे यूज करेंगे. Cu2 plus takes up 2 electrons, converts into Cu. Okay. इसके लिए E नॉट वैल्यू दी गई है कितनी? 0.34. Cu2 plus converts, takes up 1 electron, converts into Cu plus, और इसके E नॉट वैल्यू दी गई है 0.16 वोल्ट्स. ओके, 0.16 वोल्ट. नाउ मुझे निकालना किसके लिए है? I have to calculate it for this Cu plus taking up an electron changing into Cu. मुझे इस रिएक्शन के लिए निकालना है. I have to solve it for this reaction. इस रिएक्शन के लिए निकालना है. मैं कैसे सॉल्व करूंगा इसको? So I will do something like this. So इसके लिए हम क्या लिख सकते हैं? डेल्टा G. इसके लिए डेल्टा G अगर मैं लिखता हूं डेल्टा G3, एंड इसके लिए लिखता हूं डेल्टा G2, एंड इसके लिए लिखता हूं डेल्टा G1. Can I say that if I subtract delta G2 from delta G1, I will get delta G3? सर आप टाइम बहुत कम देते हो क्योंकि हमारे पास 1 घंटे का. ओके, Gibbs free method is not more hefty, it's more logical. Okay, it's more logical. So can I say that delta G3 can be written as delta G1 minus delta G2? क्या लिख सकते हैं ये? Can I write this? Delta G1 minus delta G2. Can I write this? बताइए. Yes? If I subtract delta G2, तो ये इस तरफ चला जाएगा, and I will have Cu plus on this side taking up an electron, and I will have Cu on this side. ये हमें निकालना है. Okay? Now, how do we solve this? डेल्टा G3 को हम कैसे लिख सकते हैं? -1 F E naught 3. डेल्टा G1 के लिए क्या लिखा जा सकता है? How many electrons are used over here? 2F times 0.34 plus 1F times 0.16. ये लिखेंगे हम. So E naught value will be written as 0.34 times 2 is 0.68. So this will be, ये -1 है, मल्टीप्लाई कर देते हैं तो ये प्लस हो जाएगा. 0.68 minus 0.16, answer will be 0.52. The right answer should be C. Okay, right answer should be C. Clear? If I cancel off F और -1 को इस तरफ लेके चले जाते हैं, I will get the right answer as C. So why I'm subtracting? Because simultaneous equation solve करने हैं. Okay, I have to solve simultaneous. इन दोनों equations को हम कैसे arrange करेंगे? How do we arrange these two equations so that I get this equation? So I subtract the second equation from the first one. Okay, very good Vanshika, you're like leading. बहुत अच्छी बात है. Is that clear? So this is how it will be done. ठीक है, all 3 questions correct. चलो, very good. Everybody who has given the right answer is absolutely on the point. चलिए, let's look at the next question. Next question is this. This is not a very straightforward question, but try to read the question, then try to solve this. The pressure of hydrogen gas is increased from 1 atmosphere to 100 atmosphere, keeping H plus concentration constant at 1 atmosphere. Okay, sorry, constant at 1 molar ले लो, ये इसको 1 m. The change in the reduction potential of the hydrogen half cell is. द चेंज इन द रिडक्शन पोटेंशियल इन द हाइड्रोजन हाफ सेल इज. ठीक है, सो आई एम गिविंग यू सम टाइम, थोड़ा समय लीजिए सॉल्व करने के लिए. Bhavjot says C, Prateek says C, Suman says C, Sahil C, and Swatantra says C, Ajay says A, B, C, C, Ghazala says C, Call Me Adil says C. चलो देखते हैं कैसे सॉल्व करना है. ओके, वंशिका says A, तो देखो, तो वंशिका इज ऑन द गो. सो लेट्स वेरीफाई वंशिका ने जो आंसर दिया है वो सही दिया है उसने कि नहीं. सो देखते हैं कैसे सॉल्व करना है. सो व्हाट आई वुड डू इज, दिस इज H प्लस and this is getting converted into H2. okay, I can write this half H2 यहाँ पे लिख सकते हैं. ठीक है, so if I write the Q for this, Q would be written as pressure for hydrogen to the power 1 upon 2 by H plus ion concentration. H plus ion concentration. Now हाइड्रोजन इलेक्ट्रोड के लिए हम लिखेंगे E सेल इज इक्वल टू E नॉट सेल माइनस 0.0591. नंबर ऑफ इलेक्ट्रॉन्स कितने लिए गए? 1 इलेक्ट्रॉन. 1 लॉग ऑफ प्रेशर ऑफ हाइड्रोजन होल स्क्वायर, सॉरी, pressure of hydrogen to the power 1/2 by H plus ion concentration. Okay, I'll write it like this. Now what is the half cell potential for hydrogen electrode? This looks like a hydrogen electrode. This looks like a hydrogen electrode. So अगर ये hydrogen electrode है, then half cell potential कितना होगा इसका? The half cell potential would be 0.0 volts. Okay, it will be 0.0 volts. So I will take this as 0.0 volts and I will write this as 0.0591 upon 1 log of 100 कर दिया गया इसको, 100 by 1. okay, इसका रूट ले लिया गया. So this will become minus 0.0591 log 10. Log 10 is 1. So I will get E cell has become something like this. Okay, E cell has become something like this, 0.0591. Now when it was when it was 1 atmosphere, and H plus ion concentration is 1, that will make it a standard hydrogen electrode. A standard hydrogen electrode का potential होता है 0 volts. Now it is becoming minus 0.0591. So कितने का change हुआ है? What is the change? 0.059. okay, the change is of 0.059. is that understood? Because what I have done is, you can see, if it is 1 atmosphere for H hydrogen pressure and concentration of H plus is 1 molar, then it is standard hydrogen electrode. It will be having a potential of 0 volts. It will be having a potential of 0 volts. The standard electrode potential उसका 0 रहता है. बट जैसे ही इसका प्रेशर चेंज कर देंगे, इसका पोटेंशियल चेंज करना शुरू करेगा. दैट इज द यूज फॉर नर्स्ट इक्वेशन. नर्स्ट इक्वेशन इसीलिए किए जाते हैं. सो नर्स्ट इक्वेशन में प्रेशर को 100 पुट करेंगे टू द पावर 1/2 आ जाएगा. दिस विल कम एज टू बी 0.0591. ओके, वेरी गुड, वेरी वेरी गुड वंशिका. ओके, अजय, आई गेव द आंसर फर्स्ट आंसर. चलो, बहुत अच्छी बात है. अरे यार, सही है, अच्छे आंसर, सभी लोग सही आंसर देते हैं, अच्छा लगता है. ठीक है, इजी क्वेश्चन, कोई दिक्कत नहीं है, आराम से सॉल्व करेंगे. आंसर विल बी ए 0.059. माइनस पे ध्यान मत दो, चेंज कितना पूछा गया है. ओके ओके, यू हैव बीन आस्क्ड दैट व्हाट इज द चेंज रादर देन व्हाट इज द मैग्नीट्यूड ऑफ चेंज पूछा गया है. ओके, चलिए नेक्स्ट क्वेश्चन इज दिस. When aqueous solution of lithium chloride is electrolyzed using graphite electrodes, which statement is correct? Okay? मेंटी से करवाते क्विज. देखो जतिन, पॉइंट ये है कि ना मेंटी में आई कैन नॉट यूज इलेबोरेट सेंटेंसेज. ओके, सो इसीलिए थोड़ा सा रेस्ट्रिक्शन रहता है. देर इज अ स्मॉल रेस्ट्रिक्शन दैट आई कैन इफ देर इज अ स्मॉल वैल्यू then I can use Menti, but since chemistry में हमारे पास statements ज़्यादा हैं इसीलिए. P1 by P2 क्यों नहीं हुआ? Where is P1 by P2? So what is the answer to this question? When an aqueous solution of lithium chloride is electrolyzed using graphite electrodes, what will happen? So please look over here. क्या होना चाहिए? So what should happen in this case? Okay, now in this case what we have to remember that lithium chloride is the same, would behave the same as sodium chloride dilute wala scenario. Lithium chloride scenario is similar to the sodium chloride scenario again. Now in sodium chloride scenario I had told you to remember the potential values because potential values are important. So in sodium chloride scenario I remember, if remember, then Cl minus conversion into Cl2, this E0 value was minus 1.36 volts, minus 1.36 volts, and conversion of, okay, let me write it a little more clearly so that you can understand. So Cl minus converts to Cl2, this E0 is minus 1.36 volts. Okay, water's oxidation to change into O2 plus 4H plus 4 electrons, this E0 value is minus 1.23 volts. These two reactions will take place at the anode or compete at the anode. यहाँ पे competition होगा anode पे, and cathode पे competition होगा lithium plus का Li में चेंज करने के लिए. दिस E0 वैल्यू विल बी माइनस ऑफ सम 2.71 volts and H2O converting into hydrogen plus 2OH minus taking up 2 electron. This will be minus 0.83 volts. Okay, this will be minus 0.83 volts. ये values आपको याद होने चाहिए. Okay, these values should be remembered. Now the point is, do you remember there was a concept that we had discussed about anode पे जो reaction होगा, it looks like what should be liberated? It looks like what should be liberated at anode? Water okay, it looks like this reaction should take place at the anode, but this reaction would not take place. This reaction would not take place because of a concept known as overpotential. Oxygen को convert करना thermodynamically favorable है, but kinetically it is very very slow. And overpotential मतलब we have to add some extra potential to make this reaction achieve that speed in which we can extract it. Okay, in which we can extract it. So the overpotential is about 0.6 volts और ये कितना हो जाएगा minus 1.83 volts हम डालेंगे तब जाके ऑक्सीजन लिबरेट होगा. बिफोर दैट ऑक्सीजन वुड नॉट बी लिबरेटेड. इवन दो the delta E naught value is a slightly greater than this one. It will not happen. The right answer will be chlorine will be liberated at the anode. Sodium chloride का जो dilute sodium chloride का electrolysis होता है उसमें chlorine liberate होता है rather than oxygen, and hydrogen is liberated rather than the metal. Okay, there is no effect of dilution in right now. There is no effect of dilution right now क्योंकि यहाँ पे हमने कोई concentration तो change नहीं किया है. Okay, so oxygen is liberated at anode. It is incorrect. It is incorrect due to the reason which is known as over potential or over voltage. Lithium is deposited at cathode. नहीं, cathode पे ये reaction होता है. As current flows through a solution, the pH of the solution at cathode increases. एक बात बताइए, cathode पे जो ये reaction हो रहा है, what is produced along with it? क्या produce हो रहा है? OH minus. OH minus is being produced. So if OH minus is being produced simultaneously at the cathode, will the pH increase or decrease? pH will increase. Increase होना चाहिए. The right answer should be C. pH decreases? No. Okay, the right answer should be C. ठीक है? So chlorine will be liberated at the anode and hydrogen will be liberated at the cathode, and this is utilized in chlor-alkali industry. ये sodium hydroxide बनाते हैं यहाँ से, and chlorine भी मिल जाता है and hydrogen भी मिल जाता है chlor-alkali industry में. Okay, is that understood? So the right answer is C. Anybody who has said A is wrong. The reason is over potential. Okay, चलिए वंशिका, ठीक है, बड़े बड़े शहरों में ऐसी छोटी छोटी बातें हो जाती हैं, लोगों से मिस्टेक हो जाता है. चलिए लेट्स गो ऑन टू द नेक्स्ट क्वेश्चन. नेक्स्ट क्वेश्चन इज दिस. अ गैल्वेनिक सेल इज कंपोज्ड ऑफ 2 हाइड्रोजन इलेक्ट्रोड्स. इसको सॉल्व अच्छे से कीजिए बिकॉज दिस केम इन वन ऑफ द एडवांस्ड एग्जामिनेशंस. A galvanic cell is composed of 2 hydrogen electrodes of which the cathode is a standard hydrogen electrode. Cathode is a standard hydrogen electrode. In which of the following solution should the other half cell be immersed so as to obtain the maximum EMF? I have to obtain the maximum EMF. In which of the 4 solutions should I immerse the anode so as to obtain the maximum EMF? बताइए क्या आंसर होना चाहिए. Okay, I'm giving you a minute's time. Somebody says, Urmila says B, Ishani says B, should be B. Okay, if it is B, देखते हैं. Some Ajay says D, Purnachandra Das says B. Okay, chalo, I have got enough answers right now so that I can solve the question. Question इस तरह solve होगा कि if I write the anodic reaction ये लिखेंगे हम. Anode पे क्या होता है? Oxidation. So I will write it like this. Half H2 changes to H plus. That will give out an electron, and H plus changes to H2 taking up an electron. This will be the oxidation half cell, this will be the reduction half cell. This should be first perfectly clear. Now when I write the E cell, it will be written as E for oxidation half cell plus E for reduction half cell. ये हम लिखेंगे. E for oxidation half cell will be written as E naught. E naught for this reaction is 0. E naught for this, so E naught को हम हटा ही देते हैं. Minus 0.0591 by 1 log of H plus ion concentration in oxidation half cell upon pressure of hydrogen to the power 1 by 2. ये लिखा जाएगा minus 0.0591 by 1 log of pressure of hydrogen to the power 1 by 2 by H plus ion concentration in reduction half cell. Okay, the expression will be like this. Okay, the expression will be like this. Yeah, Ishani, these are previous year's questions. Okay, the expression will be like this. I am not including the E naught value because E naught value is 0. So if I add both of them, I will get minus 0.0591 by 1 log of H plus ion concentration in oxidation half cell upon H plus ion concentration in reduction half cell. ठीक है? If I want to obtain maximum if I want to obtain maximum EMF, if I want this to be maximum, ये मुझे maximum चाहिए, then this should be minimum. ये minimum होना चाहिए, isn't it? Is that understood? If E is maximum, अगर इसको मुझे maximum करना है, then this should be minimum. Can I say this? या फिर हम इसको उल्टा कर देते हैं, 0.0591 by 1 log of रिडक्शन हाफ सेल में जो H प्लस आयन का कंसंट्रेशन बाई ऑक्सीडेशन हाफ सेल में जो H प्लस आयन का कंसंट्रेशन है. सो ऑक्सीडेशन हाफ सेल में हमारा H प्लस आयन का कंसंट्रेशन कम होना चाहिए. आई शुड हैव द H प्लस आयन कंसंट्रेशन इन ऑक्सीडेशन हाफ सेल्स एज लेस एज पॉसिबल फॉर दिस टू बी एज पॉजिटिव एज पॉसिबल, एज मैक्सिमम एज पॉसिबल. ओके, सो इन दैट सिनेरियो हम क्या करेंगे? वी विल नीड द वीकेस्ट एसिड. We will need the weakest acid क्योंकि weakest acid will produce least amount of H plus ion. So benzoic, acetic, formic, oxalic, if I write their relative acidic strengths, then H2C2O4 followed by HCOOH followed by C6H5COOH followed by CH3COOH. The weakest acid is acetic acid, and because of that the right answer for this question will be B. The right answer for this question will turn out to be B. Okay, acetic acid will be the right answer. समझ में आया? सबसे कम H प्लस आयन जहां से मिलेंगे उस केस में ये जो डिनोमिनेटर आप देख रहे हो, दिस इज ऑक्सीडेशन हाफ सेल, ये जितना कम रहेगा ये उतना ही पॉजिटिव रहेगा. Okay, clear why E naught is, it's okay. E naught value, this is a standard hydrogen electrode. Can you see that hydrogen is getting oxidized or reduced? चाहे वो E naught value तो हमेशा आप zero ही लोगे. Because you are changing the concentration, you can calculate E, but E naught will not change. E naught will always be equal. E naught will always remain constant no matter whatever condition you take. E naught will remain constant, but the change can be estimated using Nernst equation. Okay, so equilibrium पे रहे नहीं रहे, E naught value तो हमेशा constant ही रहेगा. Okay, hello अब्रजीत. Okay, D क्यों नहीं है? D इसलिए नहीं है क्योंकि ये strongest acid है ना यार, तो यहाँ पे हम weakest acid लेंगे तभी जाके ये value उतना positive होगा. ठीक है, चलिए लेट्स मूव ऑन. ओके, ये फिफ्थ था, सिक्स, सेवेंथ. चलो, नेक्स्ट क्वेश्चन इज दिस. द नंबर ऑफ मोल्स ऑफ आयरन मेटल प्रोड्यूस्ड, मेटल नॉट Fe2 plus or something else, the number of moles of iron metal produced by passage of 4 amperes of current through 1 liter of 0.1 molar Fe3 plus for 1 hour. Okay, for 1 hour, 1 घंटे के लिए हम 1 एम्पियर पास करते हैं एक सोल्यूशन में which contains 0.1 molar solution of Fe3 plus. How much amount of iron metal will be produced? Okay, how much amount of iron metal will be produced? ठीक है, बताइए what should be the answer? सीम्स डिफिकल्ट? डिफिकल्ट नहीं है यार, इजी क्वेश्चन है। पहले तो अब ये कैलकुलेट करो कि 4 amperes, that is I is 4 amperes, T is 1 hour, तो ये कितना फैराडे है? How many Faradays is this? Okay, how many Faradays is this? So this will be number of Faradays will be 4 times 60 times 60 by 96500, कितना हो जाएगा ये? Okay, how many Faradays would this be? कितना होना चाहिए? How many Faradays would this be? कितना होना चाहिए? So ये कैंसिल हो गया, so 36 times 4 by 965. What should be the number of Faradays? यार नंबर ऑफ Faradays तो बताओ, कैलकुलेट करना है। So anyways, आप नंबर ऑफ Faradays कैलकुलेट करोगे, आपको मिल जाएगा ये रिएक्शन, Fe3 plus will take up 1 electron and convert, or you can say that Fe3 plus will take 3 electron and will convert into Fe. आप लिखेंगे नियरली 6.14 या 0.15, आई गेस 0.15 होना चाहिए। ओके, दिस शुड बी 0.15. सो 0.15 will reduce 0.15 moles of any ion. Okay, 0.15 Faraday reduce कर रहा है, so I have taken 0.15 Faradays, and 0.15 Faradays is gonna reduce 0.15 moles of that ion. Now हमने कितना लिया है? 0.1. Okay, 0.1 has been taken. Apply stoichiometry. Simple equation है. This इसका 3, if I have taken 0.1 and this 3 electrons is required, then 0.1 requires 0.3 moles of electrons. How many electrons have been taken? 0.15. So number of Faradays tells you the number of moles of electrons. Number of Faraday tells you the number of moles of electrons. Okay, number of Faradays will tell you the number of moles of electrons. ठीक है, Faradays कैसे निकालना है आपने? You take the current times time and divided by 96500, you will get the number of Faradays. Number of Faradays tells you the number of moles of electrons. ठीक है, एक बार number of moles of electron आ गया, number of moles of electron आएगा 0.15. आपने कितना लिया है? 0.1. Okay, so which is the limiting reagent यहाँ पे? Which will be the limiting reagent? Limiting reagent हो जाएगा आपका Fe. Fe का अमाउंट कम लिया है आपने, electrons का अमाउंट आपने ज़्यादा लेके रख लिया है. So how would you calculate this? 0.1 के लिए 0.3 होना चाहिए था, तो इसमें से कितना रिड्यूस होगा? What should be the answer? अरे यार 2 बार तो समझा ही दिया। अब इसको 2 तरीके और एक स्टेप में कर सकते हो। Fe takes up 1 electron, changes to Fe2 plus, तो ये 0.15 है, इसमें से completely use हो जाएगा. This will be 0.05 which will be left out. This will be 0. This will be 0.1 which will be formed. Now Fe2 plus will take up 2 electrons, will change into Fe. So 0.1, 0.05. How much will be utilized? How much will be utilized? 0.1. Answer is, answer will be 0.05. कितना यूटिलाइज होना चाहिए? 0.1 के लिए 0.1 के लिए 0.2 लगना चाहिए. So 0.05 will reduce how many moles? 0.05 will reduce 0.05. So कितना आंसर आना चाहिए? The right answer should come as to be B. Use, okay, try to use the concept of limiting reagent. Try to use the concept of limiting reagent. Okay, ठीक है, try to use the concept of limiting it. The right answer should come as to be B. Now problem 8 simple question tha. Okay, problem 8 is a simple question. A graph is plotted versus molar conductivity of various electrolytes versus root C, that is concentration. The correct setting is, which will be the correct setting? The correct setting will, the right answer will be, location, stop spamming. Okay, so right answer will be, strong electrolyte के लिए ये हो जाएगा. This will be for the strong electrolyte HCl. This will be for the weak electrolyte. The weakest electrolyte over here is ammonium hydroxide, NH4OH, and this will be for NaCl. The right answer will be, 1 is for 2, 3. Right answer is B. Okay, the right answer is B. Okay, so with this we end today's session, and please do join us for the KVPY essay and SX sessions which are being held on the Vedantu channel. Please attend them diligently if you want to do really good at the KVPY examination. Okay, so with this I take leave, and I hope you have enjoyed electrochemistry. The next topic will let you know कि कौन सा होगा, probably chemical kinetics or between solid state, between chemical kinetics and solid state कोई एक start करेंगे हम. And this is all for today. Please do join us on Wednesday for another session in chemistry. If we'll make an announcement here onwards कि कौन सा topic होगा. ठीक है, चलिए, bye bye guys and have a lovely time.